What's today? Today is officially 2 weeks of No Shave November. Everyone's got a beard. Oh. Well, yesterday and the day before we were learning about medians and centroid, angle bisectors and incenter, and mid-segments, okay? Yesterday we did 2 and 1. Today we're going to do 2 more and 1. So we'll have done 5 notes for the 5 sheets that you have in your packet. You'll have tomorrow to work on that in class, and then we're quizzing on Friday. And then you will give thanks for a week of school off. All right, so let's do these notes. Okay, we're talking about altitudes and orthocenters. So, how many of y'all have ever been at a high altitude? Where were you? Escalator? Oh, the Scream? The Scream is a high altitude. And then you... Alright. Okay. Okay. So you went to the top of a mountain, and because of the pressure, the chips blew up. Nose started bleeding? Yes? You had to climb a telephone pole and jump off with a bungee cord or something? Okay. I'm glad, because, yeah. Okay, so obviously, altitude is height, and you can be at a high height, like in a plane or a helicopter, someone said earlier. Yeah. Or on the Cowboys when they're on top of the league, you know. So, let's talk about triangle altitude. So, an altitude of a triangle is a perpendicular segment from a vertex to the line containing the opposite side. Okay? Every triangle has 3 altitudes, and just like the last couple notes, when those 3 lines cross, that's called a point of concurrency, and that point of concurrency gives us a center that's called the orthocenter. Okay? So, this is the weird thing about an orthocenter. Did you know the orthocenter can be on the outside of the triangle? So, it's kind of weird to think about, but a center being outside seems different. Usually the center of anything is inside or in the center, yes. So, let me show you what I mean by that. You can sketch this for me real quick, but I am giving you the fast version of 3 altitudes on all 3 of these triangles with purple dots, okay? Ta-da! So, you can try to sketch that for me real quick. The first triangle made 3 altitudes, and they are inside. The second triangle has 3 altitudes that intersect outside, and the third triangle has 3 altitudes that intersect on the edge of that triangle. So, let me explain each one. So, an altitude goes from a vertex straight down for a right angle, vertex, right angle, boom. So that works for this triangle. This triangle, if I need to make a right angle, it's not going to make a right angle inside. I have to go straight down outside. I had to extend this side to make that right angle. And the same over here. If it really makes a right angle, it's going to have to be outside the triangle. And then this one, there should be a right angle right there. So right now you're just doing a sketch. Okay, we're going to do some examples on the back together. But I want you to notice, what kind of triangle is this first triangle? Acute, obtuse, or right? Acute. So let's fill in this bottom blank. If it's acute, the triangle's orthocenter is where? Inside. What kind of triangle is the second one? Obtuse. That obtuse triangle's orthocenter is outside. What kind of triangle is that third one? It has one right angle, so it's a right triangle. The center, the orthocenter, is on the edge, specifically on the vertex of the right angle. Okay, flip it over and start plotting those points, please. So finish writing that down, sketching that, and then flip it over and plot those 3 points. So we're plotting J, K, and L. Use your straight edge to make that triangle and label it J, K, L. Now, how do I make altitudes? Let me tell you. I want you to write this down for me, please. Altitude of a vertex uses the opposite reciprocal slope of the opposite side. So you need to know that, so write it down. Okay. Now, we're going to organize our thoughts here into columns so that way we can graph these altitudes. So I want you to make 3 columns: vertex, slope, and opposite reciprocal. If we get this information organized, it'll help us make 3 altitudes, and then we'll have an orthocenter. So let's pick a vertex, and we will start with J. Let's write that down. Starting with vertex J, what side is across from J? So across right here is this segment, which is KL, right? Or you could say LK, it's fine. So KL, I need to know the slope of KL. Now, how do I figure out slope? Rise over run. So, from K to L, you can count literally rise and then run to L, or you can do it each little step of the way, but K looks like it's going down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. It works, okay? So, what is that slope? Yeah, negative 1 over 1. So let's write that down. And then I need to write the opposite reciprocal just now. So opposite reciprocal of negative 1 over 1 is what? So opposite of negative is, and then flip 1 over 1, you get, well, still 1 over 1. So positive 1 over 1 is my opposite reciprocal slope. True? Quite true. So, at J, we are going to use the slope 1 over 1. So at J, rise 1, run 1. Rise 1, run 1. See these little points I put? At J, I'm using the opposite reciprocal slope, up 1 over 1, up 1 over 1. And then I'm going to draw that line. And that is the altitude from J to KL. Cool? If you can do that 2 more times, you will have an orthocenter. So, next one we're going to do is K. Okay? All right, now, slope of the opposite side. What is across from KL? JL. Let's write that down. And what is the slope of JL? You won't find it on your phone right now. That's for sure. So if you're trying to find it on your phone, so the slope of JL, this is a horizontal line. What's the slope of a horizontal line? 0. Very good. Did everyone know that? Horizontal, 0. Okay? So here's the next question. What's the opposite reciprocal of 0? No. No. What did you say? No. 1 over 0? Not really, because you can't do 1 over 0. What? Doesn't have one is the closest answer, because it is undefined. Y'all remember that? Undefined. So remember, horizontal line, opposite reciprocal will be perpendicular and be a vertical line. And vertical lines are not a function, and they do not pass the vertical line test. And there's no such thing as the slope of a vertical line, so it's called undefined. So everyone needs to know, horizontal from left to right is 0 slope, vertical is undefined slope, okay? So I'm going to put undefined with the vertical little line, put a little horizontal line into that 0 so I know what I'm talking about. So even though there's no slope, meaning does not exist, undefined, I'm still going to make my vertical line through point K, right? So vertical line at point K. So put a point at K and straight down. That's your altitude. So we have 2 lines that cross. You can already tell where they're going to make the orthocenter, right? But we're going to do the last one anyways. So the last one, the last vertex is the vertex that the Philadelphia Eagles have to hold this week. That L. I thought they won the Super Bowl. I guess they're just one-hit wonders, you know. All right, so now here's a good joke. You ready for this? What's the side across from L? No, I'm serious. But I'm serious. All right, but seriously, it is JK. So, what is the slope of JK? What's the rise over run? So, up 2 over 1, up 2 over 1. What? So 2 over 1 is the slope. Write that down. You could have done from J all the way to K, which is 4 over 2, but everyone knows 4 over 2 reduces to 2 over 1, right? Okay, so once we have our slope of 2 over 1, then we're going to find the opposite reciprocal slope. So remember, opposite, change the sign, and then flip it. So what's it going to be? Negative 1 over 2. Now the negative can be on top or bottom, doesn't matter. So negative 1/2 is my slope, and I'm going to put that slope, use it at point L, Philadelphia. And now here's the deal. If here's L, and I go down 1, right 2, do you see how that's going the wrong direction? Now you could still just draw the line along, but I want you to know something, if you didn't already know this. Down and to the right is negative, but so is up and to the left. Does everyone know this? Down and to the right is the same as up and to the left when it comes to slope. So that's what we're going to do. From L, we're going to go up 1 and then left 2. So up 1, left 2, put the point right there. Up 1, left 2 again, put the point right there where I wanted it, where it intersects. Okay, and then you can draw your altitude line. I'm going to put a green dot on that orthocenter right there. What is the coordinates of that orthocenter? Negative 2, 4 is my orthocenter. Could you do that? Don't say no, say yes. Don't be the Eagles. Succeed. Okay, well, let's try to be the Cowboys on number 2. Cowboys will, as you will, succeed. Not a test, it's a quiz. Every single game. Sweeping statements. That would be not knowledge and not true. So, number 2. Let's find the orthocenter of the triangle with these vertices. Go ahead and graph those 3 points. Oh, I don't want you to miss out on all the fun. You were yelling. I didn't hear any yelling. So go ahead and make these 3 columns, plot your 3 points, and make your columns like this. Here we go. So you have definitely plotted 3 points and made a triangle. And you made those 3 columns. Let's start with vertex K. What side is across from K? LM. So let's write LM. And what's my slope for LM? What's the rise over the run? Numbers, please. What's the rise over the run here? Okay, does everyone see? Down 2, right 1, down 2, right 1. That's my slope. So write that down, your slope. And what's the opposite reciprocal of negative 2 over 1? Positive 1 over 2. So at K, I'm going to rise 1, run 2. Rise 1, run 2, put a point. Rise 1, run 2, put a point. And then you can draw your altitude. Let's do it for the Eagles. L. So, L is across from KM. Now, what's the slope of KM? 0. The amount of wins the Eagles have against the Dallas Cowboys. That's right. So, 0. So, from 0, we need the opposite reciprocal slope. Undefined. So remember, undefined means it's going to be a vertical line through the vertex L, which is the Philadelphia Eagles. So again, straight down. Cool. You can already see where they're going to cross, but let's do the last one. Okay, M. So M is across from KL, or LK. Who can tell me the slope of LK? 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. It is 4 over 1. And what's the opposite reciprocal? Negative 1 over 4. Now, hold up, hold up. If I go to M, and I try to go down 1, right 4, that's off the grid. So let's not do that. What's the same thing as down and to the right? Up and to the left. So up 1, left 4, and that's exactly on the intersection that I need. So draw the altitude, put a green point, and that's my ortho center. What's the coordinates of that ortho center? 4, negative 1. Very good. All right, y'all understand ortho centers, or at least you have a way of seeing how to do it. All right, next sheet. Let's talk about, let's be really mature here. I know this is kind of difficult for some of us. We're going to talk about perpendicular bisectors and circumcenters. So, y'all know what a perpendicular bisector is? What does a bisector do? Cuts something in half. A perpendicular bisector cuts something in half and makes a perpendicular 90-degree angle. Okay? So, notice what it says here. The perpendicular bisectors do not always intersect the opposite vertex of the triangle. So here's what I mean. Look right here. This triangle on the left. That's an altitude, right? Going through the vertex. Over here to the right, this is perpendicular, but it doesn't go through the vertex. It goes through the midpoint. This is a perpendicular bisector. Okay? This also is a perpendicular bisector, but it happens to also be an altitude. Okay? So I just want you to see the difference. Altitudes go through a vertex. Perpendicular bisectors go through a midpoint. They're kind of similar, but they go through different parts of the triangle. That's why we have a different center for this one. It's called circumcenter. Now, down here, just like orthocenter, they can be in, out, and on. Okay? So the acute triangle, where's this center? Where's the circumcenter here? Inside. Write that down. Where's the circumcenter for the obtuse triangle? Outside. What about right? Right on. Cool? So orthocenter and circumcenter can be in, out, or on. Okay? Now, very bottom, there's something you need to know about circumcenter. So, first of all, if it's a perpendicular bisector that cuts every side in half. Is everyone hearing me? Every side is cut in half. How do I know that? Look at my picture. Do you see the tick marks? 1 tick, 1 tick. 2 tick, 2 tick. 3 tick, 3 tick. Okay? Now here's the deal. I should know, based on this theorem right here, PA equals PB equals PC. Okay? If I know that, then I know these blue segments are congruent, right? So, PA, PB, PC, we're going to put tick marks on that to show that they're the same. But I already have 1 and 2 and 3, so I'm going to put one number to remember. 4. So, we're going to put 4 tick marks on these 3 segments. Okay? So, Jeff Davis is really happy. So put 4 tick marks here, 4 tick marks here, 4 tick marks here. Okay? So does everyone see all the different tick marks? There's cut in half on the side, cut in half on the side, cut in half on the side. And then you have those equidistant segments to the vertices. Not the sides, but the vertices. All right, flip it over. Okay, number 1 here. Now this might look easy or hard, doesn't matter. The point is it can be really easy if you label everything. Is everyone's heads up? So, check it out. You know if it says perpendicular bisectors that you need to label all the tick marks. So, since these are bisectors, that means K is a what? Well, but it's a point. Midpoint, thank you. So if K is a midpoint, what do I put on these 2 segments? 1 tick and 1 tick. Now, what about L? L is a midpoint, so what do I put next to those? 2 tick, 2 tick. Okay, M is a midpoint, so I put 3, 3. So, for sure, if you have perpendicular bisectors, you should show me, you know that, with those tick marks, okay? And we just learned from the circumcenter to each vertex is equal. So I'm going to put 4 tick marks on each of those segments. From Z to G, from Z to J, and from Z to H. 4 tick marks. Now, if you can label all that, then this is going to be easy. Walk in the park. Okay? Look at A. A says HZ. How many tick marks is HZ? 4 tick marks. Now look at these other 4 tick marks. Are any of these labeled? Oh my goodness, this is what? If this is 19.9, then this is 19.9. Easy. Okay, GM is how many tick marks? 3. Do I know the other 3? I do. 14.5. Easy. GK is how many tick marks? 1. And it's not 19.9, by the way. Right? 18.6 is 1 tick mark. So that means GK, 18.6. Okay, JZ. We hang out sometimes, you know. JZ is how many tick marks? 4 tick marks, which is 19.9. That was easy, right? If you know what you should know about perpendicular bisectors and a circumcenter. Now, to make this harder, number 2. Are we good on this? All right, y'all ready for this? Write this down, please. And then graph that triangle real quick. Okay. Now, this is a little different than orthocenter. This one says perpendicular bisector of a side uses the opposite reciprocal slope through the midpoint. Okay? Give you a minute. Write that down. we're going to make 3 different columns. This is different than orthocenter. Instead of starting at a vertex, we're starting at a side. We're going to find the side slope, figure out the opposite reciprocal, but this time it's going to go through the midpoint. Okay? So make sure you're writing this down. Let's pick a side. RO, good job. So RO is a side. Do we know the slope of RO? 0. It's a horizontal line. So what's the opposite reciprocal of 0? Undefined, because it's vertical. So here's the deal. You're going to use a vertical line through the midpoint of RO. What's the midpoint of RO? Halfway between 0 and -6 is -3. Put a point there. And then make your vertical undefined slope line. So I wrote down my midpoint right here, and I did my vertical line. By the way, what kind of triangle is this? Right triangle. So we know from the front side, right triangles have a circumcenter that's on the edge. Right? Next one. Let's do shout out to SO. Get it? Okay. So SO is what slope? Vertical is undefined. So what's my opposite reciprocal slope? 0. What's the midpoint of SO? 2 on the y-axis, which is really 0, 2. And go ahead and make your 0 slope a horizontal line. And you can see where they're going to cross, right? So real quick, RS is my last side. The slope is going up 2 over 3, up 2 over 3. So 2/3. What's the opposite of 2/3? -3 over 2. And I need to find the midpoint of RS. So RS is horizontally 6 units. So half of 6 is 3. Go straight up. Put a point right there. And make my slope of -3 over 2. Down 3, right 2. So from here, we go down 3, right 2, put a point, and draw our line. And now you can see where that circumcenter is. Where's it going to be? -3, 2. That's it for these notes, and actually for all the notes for this week. What I want you to do is use these, all 5 of these notes, to do the 5 pages you have in your assignment from that packet. So you didn't lose it, you got it, keep working on it. All right, so let's get started.